Hello everyone, my name is XingMin. I'm a PhD student at Rice University. I'm working with Dr. Jonas Osoro on the design of interdependent infrastructure system. Let's start from the background of this research. If we look into the current research in infrastructure design, for example, the American Lifeline Alliance guidelines, they provide a lot of ASCE codes, ASME codes to illustrate how to design individual node or pipeline in one network. However, the interdependence between different networks has never been considered in these design guidelines. This is a figure from Department of Homeland Security. In modern society, different lifeline networks are highly interconnected and rely on each other to keep their efficient operation. So, the interdependence between different networks has a substantial effect on the reliability of the whole multi-network system. Under this consideration, the interdependence should not be excluded from the designing process of lifeline system. This is what we try to solve in this research. In this research, we choose interdependence as one of our main design aspects and explicitly consider the interdependence effect on the reliability of the whole multi-network lifeline system. Most of the former research in lifeline interdependence focused on its negative effects. In this research, besides the negative effects, we also look into the positive effects brought by interdependence. The design parameters in this research have been chosen from two aspects. The first is for the component reliability, including the reliability of the nodes, like the pump stations in water network, the power plants in power networks, and the reliability of the links, like the water pipelines and the power transmission lines. The second aspect is the interdependence interface. We will design the interdependence interface from coupling density and coupling strength for interdependent links between different networks. This is a picture which describes the whole design process in my research. In this picture, from left to right, is a regular forward reliability assessment process. What we do in this research is in the backward way. We started from a prescribed reliability index beta for the whole system, and our objective is to find the interdependence interface and the network component reliability, which directly corresponds to the desirable reliability index. This is an inverse reliability problem. Usually, the inverse reliability problem has been changed into optimization problem and then be solved by some numeric methods. In this research, we also changed the original inverse problem into optimization problem, and because there are many design parameters, we choose the genetic algorithm to solve the optimization problem. So what we used in this research is a genetic algorithm-based inverse reliability method. We use a two-network lifeline system to illustrate the proposed design method. The two networks are power network and water network in Western Tennessee. The hazard we considered in this application example is the seismic hazards. To look into the interdependence influence on the reliability of the whole network system, at first we fix the fragility of nodes and links, and find the network performance and the seismic hazards for different interdependent interface style. These figures are the results at a low PGA level. It can be easily found that An increase in coupling strength will lead to an increase in both collectivity loss and efficiency loss. That's the negative effect of interdependence. However, an increase in coupling density will result in an increase in collectivity loss. That's still negative effects, but a decrease in efficiency loss. This is the positive effect we are looking for. However, when it comes to high PG level, things has changed. The positive effect which we have found at low PG level will disappear. Both of the increase in coupling density and coupling strength will bring a heavier collectivity loss and efficiency loss for the whole two-network system. A reasonable explanation for this phenomenon is that at high PG level, most of the water pipelines has damaged. So even we increase the number of coupling links, the operational efficiency for the system as a whole will not improve. Here is the design results for component reliability and interdependent interface using the proposed design method. Through the comparison between the design values and the value of the real-life network, we have some interesting findings. It can be concluded that to strengthen the current lifeline network, we should decrease the coupling strength and increase the coupling density. And for the design of component reliability, the reliability of the nodes in current network seems enough. However, the reliability of water pipeline should be strengthened. This is all about my research. Thank you for watching this video.